All right. This answer here should really be if you did that, you probably have 662.25 pi. That's probably what you have. And then this, you probably have 2080.5. Depending on which one you did. I don't really care each way. Sketch the net. There and there. Right? I don't really care. There are your two answers there. That's 7,853. Point blah, I don't care. Yes? Anybody need to ask about either of these? Remember, do not try to copy it all down if you didn't do your work. It's being recorded. That is on you. To B. Okay? Find the volume of each solid. So, what's the volume of every single pyramid? Kinda. The volume of every single prism is length times width times height. But what's a better way to say that? Because not all prisms are length and width. Right. Volume is base area times the height, but it's a pyramid, so we divide by 3. So the base area, it's a base of 4. Well, if it's a square pyramid, that means the base is 4 squared, right? Times the height, 15, and then divided by 3. 16 times 15 divided by 3 is 80. All right. And there's the last two with pi and regular, pi and regular. I don't think that's exact. I don't really care, of course. 776 pi equals 24,429.0 blah. Who cares? Right? All of you should already be seeing how these are actually the easier way to do this. Don't waste your time converting pi. Just leave it. Right? Now we get to the tough stuff. These require thought. So, I'm going to take a second to explain them. If there's no hole cut in that cylinder, then you just need the surface area of a prism, right? Which is 2WHHLLW. Easy peasy, right? But then I cut a hole in the prism, which means if I dip that in paint, will there be pink paint on this hole? Yes, which means that's a new surface. So I must add the sides of the cylinder, just where it's pink. 2 pi RH. But this is a hole that was cut, right? Can any paint stick to the hole? No. So that circle and that circle are not surfaces, so I must subtract them. Does everybody understand? If you don't have the right answer now you should know why. Now, since I left it in real life form, right? Your answer would be something like, if you didn't 9,400, that's about 900. You'd have about 8,500. Right? Okay. Now, a lot of kids have real trouble with this. How can cutting a hole in something increase any of its measurements? But it should be pretty self-explanatory, yes? Once you see it. Here's a prism, right? If I poured paint on that, right? There's 6 faces that would have paint on them, right? If I cut that in half, now that one has 6 and that one has 6. So there are 2 new faces to get paint on them. Everybody understand? So even though I am removing stuff, I am actually increasing the surface area. Okay? Volume, so every kid, okay, I get it, all right, yeah, I understand. Then we get to volume, and then they all start, okay, so if it's volume, I must have to add something because I made something new. I haven't. In volume, this is all gone. It's empty space now. So all we do is subtract. Cool? All right. This one. If that hasn't been cut off, then I have that whole cone, right? I got this big black cone. Pi r squared and pi r slant, right? But then I cut it off. So I removed the pi r slant of this small cone, didn't I? But I gained the pi r squared of the small cone. Everybody still okay? All right. And then volume is just big cone minus little cone. So pi r squared plus pi r slant for the black cone. Then I added the pi r slant. All right, sorry. I did my math badly here. I removed the surface area of the cone's sides, right? So I lost pi. Change color. I'll change color. I lost the pi r slant, but I gained the pi r squared. Right? And how do I find the slant heights always? Pythagoras. 9, 15. So this was 17. Right? Or the slant was 15. 9 and 9 and 12 and 15, and then 3, 4, and the red slant was 5. And then volume, big cone minus little cone. This one, it was the surface area of a whole cylinder, yes? Right? But then I cut it in half. So what happens to all these 2's? Cancel, cancel, cancel. And then, but as soon as I cut it in half, I created a new square or a new rectangle, so I had to add the LW that was green. Yeah? Excellent. And lastly, a hemisphere. Surface area is just 3 pi r squared. Volume is 2 pi r cubed. And lastly, I explained what a silo was if you didn't actually know what a silo looked like, so you just added the 2 volumes together. Everybody good? Yeah? Yeah. All right. So, one group got this question right. They claimed they're gummy bears. Why did I draw it so badly? Because I want you to think. If this is 1, then how long is that? 1. Then how long is that? 7. So this really looks like this. One, 7, 1, 15. Yes? Which is a rectangle and a triangle. Why am I showing you rectangles and triangles when I'm talking about volume? Well, doesn't that shape repeat that way? So isn't that the base? So I find this area, which is 15 times 1, which is 15, and I add this area, which is 7 times 15, which is 105, divided by 2, because it's half, is 52.5. So this is 67.5, yes? Times 6 equals 405. But am I filling the pool? No, I'm only filling it 85% full to get 344.25 meters cubed. I divide that by 1.8 and I get 191.25. Or, if you're really going to do it properly, 191 hours, 15 minutes. Yeah? Huh? You wanted to go to days? You're a crazy man. So, if you went to days, you divided that by 24, then you took the leftover divided by 60. You took the leftover divided by 60. Crazy. All right. This one you had to be smart because you had 344.25 meters cubed, but you needed centimeters cubed. And if you hadn't been paying attention to me, you would have gone, oh, that's easy. Meters to centimeters just times 100. That's meters to centimeters. Meters cubed to centimeters cubed would be times 100 cubed to get 344,250,000 centimeters cubed, which, of course, you would divide by 1,000, cancel the 3 zeros, and it's 344,250 liters. Now, a bunch of kids only did the 1, and they said 3,442.5. Then they divided that by 1,000 and got 3.442 liters. I have had kids hand that in to me. That's a liter. Does that 3 times fill a swimming pool? No. If you do not know what you're doing and your calculator gives you an answer and it makes no sense and you write it down, I will mock you endlessly. All right? Now, since I know in the 21st century or the 3rd millennia of our society, the only thing worse, actually no, because according to lately, nothing is worse than being mocked. Because apparently, you would rather have someone punch you in the nose than say something bad about you on Facebook or whatever it is you choose to use. I do not understand that personally. If someone calls me an a-hole on Facebook, I say, okay, I don't care about that idiot. But if someone walks up to me and punches me in the nose, that actually hurts. I don't want any part of that. All right, my favorite question all year, because every kid does the same thing. You're filling the net, it must be volume. Of course not. Because let's pretend this is the red line. Here is the goal. From a bird's eye view, I'm looking down on it, yes? What shape is a puck? looking down on it from the top, it's a circle, yes? Right? So if I had to fill the net, I would line the pucks up this way, wouldn't I? What do you see right there? Empty space. So even if you filled the net with pucks, there would still be empty space, wouldn't there? So you cannot do it with volume. What you really have to do is this. This was 1.83 meters, yes? What are the pucks measured in? Centimeters. So what should I do to that number? Change it to 183 centimeters, yes? How deep is the net? 1 meter. 100 centimeters, yes? How big is a puck? No. I want this because we're looking straight down on it. So 7.62. So what do I have to divide that by to know how many pucks I can go backwards? 7.62. What do I have to divide that by to know how many pucks I can go across here? 7.62. So on the ground, to fill this space, I would need 24 pucks, right? And I could go back 13. So this layer would be 24 times 13, which is 312. Agreed? That's the bottom layer. Now, how tall is the net? So now we already know that now we're looking up and down, right? This is still 183, but that doesn't matter. This is now 122, right? And I know there's a layer of pucks down here that are 312 big, right? How many up can I go? What do I got to divide by? How thick is a puck? 2.54, which gets me something like 48 pucks, but I can't remember. It's 48. So that means how many layers of pucks can I fill up? So what do I do with 312 and 48? Multiply them, and you get 14,976. It's not volume because there's empty space. Everybody cool? How could I change this question to make it volume? What would I have to do to the pucks? I'd have to have square pucks, or I'd have to melt them down into a big puddle of rubber and then pour it into the net. Everybody understand? All right. What was the challenge with this question? Got to use pi, right? Because this is the only part where the paper is, yeah? So that is 2 pi RH, right? All right. So 2 pi RH is 2 pi times 4.25 times 12, yes? So one can was 102 pi, right? That's one can. How many cans do I make? So I got to multiply that by 100,000, don't I? Right? Which is, I always don't put enough zeros here, 10,200,000 pi centimeters squared, right? Everyone agrees? Okay. Are centimeters a sensible thing to measure a number that size in? No, we'd probably use meters, yeah? Okay, so if I'm going to convert that to meters, I got to divide by what? Centimeters to meters. What do? We divide by 100, but squared. So what do we really divide by? 100 squared, which is 10,000, right? So everybody cool? So I would divide by 10,000. What's going to happen to all these? They're going to go away, and I got 102 pi total. Yeah? 102 pi meters squared. Yo. Well, 10,000 has 5 zeros. No! 10,000 has 4 zeros. Thank you. 1,020. Yes. Yeah? Now, next they said how much of the classroom walls. I saw Jordy's group estimating the length of the classroom. How far was it that way? About 8 meters? Okay. So our classroom was 8 meters this way. How far was it this way? You say 9 meters? Excellent. Now, where do the walls go? Up. Now, was it possible to climb up the wall? Of course not. So what did you have to do?
We measured cadence, and then we estimated the amount of cadence that could climb up the wall.
Sure. No, nothing wrong with that, right? So, there was all the way around. You, of course, were estimating, so you didn't bother with the rectangles and all that, and the windows and all that crap, right? If I were you guys, I would have gone up to that triangle, because that's the same all the way around, yeah? Yeah. So I would have said this wall, how many cadence did you say went up? 3.5. 3.5? Wow. Cadence tall.
Or 4. Yeah, we said 4.
Well, what size is Caden then?
182 centimeters.
182 centimeters. So 4 times 1.8 is 7.2 meters. So that's 7.2. So this wall by the windows was 8 by 7.2, yes? How many of those walls are there? How many walls are there?
4.
No. 2. That one and that one. Because these walls have the triangle, don't they? So there was 7.2 by 8 by 2. What is that wall? 9 by 7.2, right? Right? 7.2 by 9 by 2 plus the triangle. The triangle is 9. How tall would you say it is from that corner up there? You got to estimate. What do you want it to say it is?
Are we measuring by cadence?
Well, if it was 4 cadence up to there,
Yeah.
right?
Yeah.
Up to the edge of the triangle, up at the top, and I really need a laser pointer to do this well, but shut up your face.
But
What?
So, according to these clowns, that is 7.2 meters. So straight across there, they said was 9. So what do you say is... I'm getting there. This is 9. What do you say that is? I think that's at least 1.5, 2 cadence. So let's say it's 2 cadence, that's 3.6 meters. That's whatever. So 9 by 3.6 cut in half, but there's 2 of them, so just 9 by 3.6, right? Now, what if you didn't have these numbers? Do I care? No, because what matters here? That you're putting it together to make a measurement. Now, and it has to make sense. You could not say the length and width of this room was 1 meter.
No.
Right? It had to be a sensible estimate, which is why you can vogue all you want, but that is... No, that's voguing. I will make you watch the entire Madonna Vogue video if you disagree with me again.
I disagree. I disagree.
All right. So that, first of all, I'm going to estimate. I don't care about these decimals. 7 times 8 is 56. 56 times 2 is 112. 7.2 times 9 is 63. Times 2 is 126. 9 times 3.6 is 9 times 3.5, which is 27. And then half of 9 is 5. 32. And I would add all that up. And that would be meters squared, yes? And what would I do with that number?
Dance.
I would not dance with the number.
Compare.
I would add it up to get 0, carry the 1. 6, 7, 270 meters squared. Right? How much paper am I using? 1,020 pi, right? Which is like 3,500, yeah?
100%.
So how many times could I cover it?
Like
10
10.
times would be 2,700,
Okay.
right?
Control Z 5.
Bigger. It's like 15.
15.
There you go.
Wow.
All right. And lastly, how far can you travel in one turn of the wheel? How far can you turn in one turn of the wheel?
Yes. How do you find the area?
You don't need the area. You need the how far the wheel goes. Pi d. So 52 pi. I need that answer in feet and inches. Well, 52 pi is 163 inches. Divide by 12, figure it out. Meters and centimeters, get the inches, convert it to centimeters. 163 times 2.54. Excuse me. 1,000 meters divided by how far he would go. And I believe it is 4.14 meters. And then down at the bottom, the little wheel is 18 pi in inches, which you would convert to centimeters, which you would then divide that, to centimeters, which you would then divide by 100 to get meters, which you would then multiply or divide all that under 1,000. I can't remember what the number is because I don't care what the number is. I only care about the math. Yeah? All right. Turn the page over. Where the heck is it? What? Your next page says solving formulas. And it should be page 239. And yet it is not on my screen. Garumph. Very frustrating.
In this time, you could be showing us Madonna's Vogue.
The Madonna's Vogue video. Okay, no. What I'm asking you to do here, there's two ways you can do it. There's the way that you want to do it, and then there's the way that your teachers want to see it done. And it's really frustrating because I don't really care, and nor should they. All right? Here's what's going to happen. When you go further in math, you're going to get formulas. When you go in science, you're going to get formulas. When you go in chemistry, you're going to get formulas. And for some strange reason, some teachers expect you to be able to. Now, that first one is, what is it? It's surface area of a cone. All right. So SA equals pi r squared plus pi r slant. And the question says, find the slant height, right? Now, some of your teachers in the future will insist that you can take this and isolate S without putting in any numbers. Of course you can. It's easy to do. But it's way easier to put the numbers in. But I would be derelict in my duties if I didn't show you how to do it without putting numbers in. So let me show you how easy it's going to be. If I gave you this question, 3x plus 2 equaled 12. No, I don't want to do 2. 3x plus 4 equaled 12. Don't write this down. What would you do? You'd isolate x, right? So you'd get rid of 4. You'd get rid of 4. 3 was a bad number to use there. Let's make it 2. No. Let's make that. Keep that 3, but let's make that 16. Right? Then 3x would equal 12. X would equal 4. Right? Okay. Now, what if I changed this to 3x plus 2y equaled 16? And I told you I wanted x isolated. Well, would you not subtract 2y? So you would have 3x equaled 16 minus 2y, yes? And then what would you do? You'd divide by 3, and x would equal 16 minus 2y over 3, correct? None of you would do this way. But that's what your future teachers will want you to do. They will want you to be able to move this stuff around with no numbers in it. So I'm going to show you how to do it once. Then I'm going to say do it whatever you see fit. All right? So if I want to isolate S here, where should I start? If I'm going to end up with S being by itself, where must I start? If I'm going to drive to Disneyland from Abbotsford, where must I start? Abbotsford, as far away from Disneyland as possible. So, where in this equation is as far away from S as possible? Pi r squared. Now, a great many of you will see and say, oh, that's pi times r, so I got to divide by pi r and r. Of course not. Because pi r squared is just a number, isn't it? Like 3x plus 2y equaled 16. That's just a number, yes? I don't care what y is. I'm looking for x. So that is a value, isn't it? So that whole term has to move over here, doesn't it? So I get surface area minus pi r squared equals pi r slant. Now, this is moved over here, 16 minus 2y, 3x equals that. Now what do I do? What should I do over here? Why, Nika? But why did you choose division? Because division is the inverse of this, yes? Well, what math is happening right here? So what do I need to do? Divide. 1 second. My son is calling me, and they are not at home, so I need to know what is going on. What? What? Missed call. Pain in the ass. So I would divide by pi r, right? So what do I do here? And now I'm done. Just moving the letters. Kind of. I have a job. What? Don't worry. All right. Everybody good?
Yeah.
Now there's a problem here with number 4. Number 4 says h equals negative 4.9 t squared minus plus 12t plus a. And it says I want you to isolate a. Easy to do, yeah? What has to happen with that? What's the reverse of negative 4.9t? Add. So h plus 4.9t squared. What do I got to do with that? Minus 12t equals a, yes? And then I told you what's the next piece of information. Height is 100 plus 4.9t squared minus 12t equals a, yes? Everyone okay with that? Can we go any further? No, why not? It's 2 variables. I would need a system, wouldn't I? Right? We would need a system that I haven't given you. Everybody cool? So sometimes you can only go so far. You cannot get any further. You have to know when you're done. All right? All right. Now listen to me and listen to me carefully because this is weird because we are in a weather situation now. All right? The next thing in your book is a review. I'm going to talk about that in a minute. That review is due tomorrow. I'm giving you the rest of the period to work on it. It's almost an hour. All right? If school is canceled tomorrow, it won't be. But like I keep telling my kids, don't walk on that wall covered in broken glass. Why? You might get hurt. I won't. You're right, exactly. People plan their accidents. That's why they're called accidents, right? That's why we call when 2 cars crash into each other and on purpose. Okay. I am covering my butt in case school is canceled tomorrow. Listen carefully. If school is canceled tomorrow, this review, I will post a key. That key will be available on YouTube, meaning this review will not be marked, but you will be writing a test on it on Wednesday. Clear? If school is on tomorrow, we will mark the review as an assignment, and you will write your test Wednesday. If school is on tomorrow, and we mark the review as an assignment, but school is canceled Wednesday, when will you write your test? Thursday. Clear? Good try, Simmer. And I like how you said it really loud so I would hear you, but in this case, that wasn't right. Everybody good? Now, listen to me carefully. I am relying on you people to tell your co-workers in this class to do that review, because I know they're not all going to watch the video. All right? All right. Now, the next thing is when you look at that review, it starts with a bunch of conversions. If you look carefully, you will see that a few of those conversions are not on your sheet. But they're all metric, so you know what to do. Right? Because metric always works. Now, let's go through this. There's a couple of weirdo spots. 1, this sit down. Sit down. 1, first problem. These did not photocopy well. I do not want this distance. Okay? I want as if it started at 0. I will accept a range of distances there because the photocopying is crap. You don't have to do any subtraction there. Assume the ruler went all the way. All right? Next one. Number 31. See how that says that's a bonus? Half of you are immediately going to go to that and spend the entire block trying to get a 10 gummy bear bonus. That's fine. Just remember, the rest of the review is actually for marks and is actually due tomorrow when you walk in. So if you aren't planning to do homework tonight, do not spend the whole day trying the gummy bear question. All right? And finally, this thing back here, I don't think printed for you. So you don't need to worry about it tomorrow or on the video when I get to here. All right? But if you do watch the video, because I make a video, you could try the question. You could pause the video, write it out, and try it. Because it's a good question for math class. It's not a great question for real life because you would never measure something at 5/8 of an X foot. All right? All right. If the unforgivable and unforeseen happens and we lose more than one day this week, that is not a problem because trigonometry is very easy and it is not absolutely necessary to do all the trig I like to do in pre-dip 10. Okay? Part of it is absolutely necessary. Part of it I added in because in the past, sometimes I have some spare time at the end of the year. All right? If I don't have it, it doesn't hurt you to not get it. If I do have the time, we'll do it. All right? Go. Avnor, go.